Okay, let's do another pedigree analysis problem, this time with a sex-linked recessive disorder, hemophilia specifically, but all sex-linked recessive disorders would follow similar patterns. Again, we're going to assign some notation and determine, in other words, we're going to assign alleles, and determine the genotypes of each person. Well, we seem to have a female here, so definitely that's going to be individual 1-1 is going to be XX, and individual 1-2 is an XY. And now we've got to figure out, is she a carrier of this disorder? He definitely doesn't have the disorder, so we in fact know he is little h. Not little h, big H, and Y, so he's not a carrier. We definitely know his genotype and his phenotype. She could be a carrier. We know she's a carrier because of this offspring right here. So she has one allele that's good and one with the disease. Now we'll continue this on the next page, but we've got our parents up at the top. Once we get our parents up at the top, we can work our way through this. Alrighty. Always start with our alleles. Our alleles in this case are going to be big H. This is no disorder. And little h, this has the disease, or has the disorder. And a reminder that we're talking sex-linked, so it's on the X chromosome, sex-linked, and it's recessive. And that is why we use the little h right there. If it was sex-linked dominant, we'd use a big H. But in this case, it's sex-linked recessive. Once again, starting at the top, we just looked at this, but definitely that is a female, X, and we know she's a carrier. Think about it again. How do we know she's a carrier? Because one of her offspring right here. This is an affected male. We know he is not a carrier just by simply looking at him here in the pedigree. So he's got the big H and the Y. Let's continue on. Individual 2-1, well, that is the affected male. So of course, male, XY, recessive disorder, little h. Now, what we're going to do here, we're going to do a Punnett square. We're going to do our parents and Punnett because that's going to help us figure out for sure what these offspring are going to be. So we've got this female carrier crossed with an unaffected male. Plug this into a Punnett square. This is the power of a Punnett square. It can help us determine what the chances of offspring getting a genetic disorder. And these are truly used by doctors and specialists who are doing genetic counseling for parents. All right, carrier female and unaffected male. Let's see their offspring. Okay, unaffected female. Unaffected but carrier female. Unaffected male. Affected male. All right, so there is our affected male right there. This individual 2-2, well, again, definitely a female. Hard to say. There's one of two possibilities. We don't have any offspring. If this individual had offspring, we could tell. Well, we'd have a chance of telling. So this individual is either that or is a carrier. Without any offspring, we can't tell for sure. Individual 2-3 is definitely a carrier because of her offspring right here. Big H, little h. Individual 2-4, that's a male. So that is a healthy or non-diseased male, XY. last column here. Individual 3-1, that is a affected male. So that is going to be X, little h, Y. Now their offspring. Do we need to do a Punnett square again, or do we already have this? Looks like we've already got this Punnett square for these two. Individual 2-3 and individual 2-4. We'll just make sure you can see that right here. This Punnett square applies to them as well. So therefore, we do for sure know some things about their offspring. We've got that one first off the bat. Okay. This is a female, but we can't tell whether it's an affected female because we've got no offspring from her. So she could be a completely healthy, or she could be a carrier. Big H, little h. Hard to say. Individual 3-3 is a healthy or unaffected male, so we know that for sure. An individual 3-4, again, could be one of two genotypes, either a homozygous unaffected or a carrier carrying that recessive allele. There we go. That is how to do, again, a pedigree analysis, and in this case it was sex-linked recessive. Let's see what we're going to